All right, Advent of Code, day 3 in Rust. I wasn't sure if I was going to do this tonight or tomorrow morning, but I'm not feeling too tired right now, so we might as well just do it. This one just got dropped about 5 minutes ago. I'm not trying to get leaderboard or anything like that. I'm just like programming, and we'll see how much we can get done tonight. Hopefully it hasn't gotten to the point where it's so difficult that I can't do it in half hour sitting, but we'll see. So let's get into it. All right, day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter is to check the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, so that's a big example right there. Considering only the first bit of each number, there are 5 bits 0. Okay, and by first bit, they mean the leftmost bit. And 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. The most common second bit of the numbers is of the diagnostic report is 0, so the second bit of the gamma rate is 0. The most common value of the third, fourth, and fifth bits are 1, 1, and 0, respectively. So the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 1, 0, 1, 1, 0, or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit for each position is used. Okay. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, and then multiply them together. What is the power consumption of the submarine? Be sure to represent your answer in decimal, not binary. Okay, let me think here. Are they doing big endian or little endian? Let's see. The gamma rate is 10110, or 22 in decimal. So what is this? 4 plus 8. I'm sorry, 2 plus 4, 6, plus 16, 22. Okay, so they're doing, I don't even know what big endian or little endian is. Basically, they're just doing it in a reading order here. Great. And then the gamma rate is it's either 1 or 0 based on whether the values in that particular digit, it'll basically pick the most common one. And the epsilon is the inverse of that. So what we were really talking about is just figuring out the gamma rate, taking the bit flip of that, which I don't even know what the bit flip operator is in Rust, either a tilde or an exclamation point, and then multiplying those two things together. Although the bit flip is a little bit maybe weird because it would cause all the leading zeros to become 1, which we don't want. Now, in terms of actually figuring out for each digit what the most common thing is, we could obviously keep a counter for each digit for the number of zeros and the number of ones. But there's really only 2 values, so what we could do is just say anytime you see a 0, let's say we just have a counter for each digit. And every time you see 0, you subtract 1 from that counter. And every time you see a 1, you add 1 to that counter. And if at the end of it, the counter is negative, then you want that digit to be 0. And if the counter is positive, you want it to be 1. If the counter ends up being 0, then you're kind of screwed because it means that you had an equal number of zeros and an equal number of ones, which hopefully is not going to be the case here. And then we're just going to have to figure out how to, parse a binary value. Or we don't really need to parse binary today, do we? We just really need to split each line into individual zeros and ones. And then to calculate binary, I think we can just, kind of brute force it. We'll just keep a vector of ones or zeros, and then just multiply. We'll do some exponentiation there. Powers of 2 shouldn't be that big a deal. Okay, so let's go ahead and create a directory for day 3A. All right, now that that's there, let's make day 3A. Let's go ahead and run that bad boy. Oh, and I keep forgetting, I gotta get that chat open. Man, oh man. All right, now that we've got that going, day 3 is running. Let's go ahead and crack open main.rs and let's try to at least parse our input here. First off, let's just take a look at the input file. That's obviously not hello world. Let's go ahead and grab it. Let's copy that. Okay, what are we looking at here? We are looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 12-digit binary numbers. Yeah. Okay. Now, if we have updated the input, this should definitely just spit out some binary numbers. And then what we want to do is actually split those up. And I think probably the easiest way that this is we can use to work with these is maybe a vector of vectors. Let's just do it like that. All right. So what we want here, our result will be we're going to grab the input. I think I need to reload Visual Studio Code here. It kind of seems like Rust Analyzer doesn't really recognize the presence of new Rust files when I copy directories like that. A little weird, but whatever. Oh, that's not what I wanted to do. Get input. We're going to split it by new lines. This is going to become a very common thing for all of these projects. And then for each line, we want to split the line into characters. And I think we can do that by doing a line dot as chars. And chars is what exactly is chars? Returns an iterator. So let's just collect that into a vector of char values. And then we'll collect that into a vector. Is that? Oh, I need to do the turbofish here to do the actual typing of it. And then this is going to have a hard time figuring out what I want. So what if I called this vector of a vector of chars? Technically, the interior thing is an array of 12 units, or array of length 12, but maybe we can just not worry about that. And then I think, let's see if the Rust compiler is smart enough to avoid forcing me to specify. Oh, it is. Magical. Just some fancy algebra there. All right. So now let's actually print that out using a debug print and see whether we got that right. It's going to be hard to read this output, but we'll see. Boy. Okay, let's just take a look at the very last line. 1, 1, 0, 0. And let's take a look here. Very, very last line. Let's go to the end. 1, 1, 0, 0. Bunch of ones, and then it ends with 0, 1, 1, 0, 1, 1. Okay, that looks pretty good. Let's take a look at the first line too. I'm gonna go ahead and clear the terminal output and then run it again, and then just make sure our first line is looking good. Let's go all the way to the top here in the text file. 0 and 4 ones. 0 and 4 ones, and then it ends with 1, 1, 0. And so, okay, so I think we've parsed the input correctly. I always got to check. I always make mistakes doing that. So this time got lucky, got it right. All right. So we will make another vector that will be the total number of... It'll be that counter for each digit position that I was talking about before. So let us iterate over, let's say, for digit in 0 to the size of the interior vector, which is really 12, but I don't want to use the knowledge of that. So let's just say input 0.len. Let digit counts be a new vector. And there's no inference yet, but I think we'll be able to infer from this in a second. So for each digit, maybe what we should do is let's loop over the input. For row in input, right? And for each of those digits, we are basically going to say that the digit count starts off as 0, and then let's make this the outer loop. I don't think it technically matters. I think there may be more cache, might be better in terms of cache coherency to go the other way, but that's not super important for this program. So the count for the digit we're going to put up here, and then what we're going to end up doing is just like pushing onto the end. Is it push? Yeah. Count. Great. All right, so now we're looping over the rows of the input, and we're basically going to say count plus equals, let's just do this. If row digit equals the characters 0, then we're subtracting 1 from the count. Otherwise, we're adding 1 to the count. Right? Input.into iter. So every time we iterate over a vector, we have to do iter here. Now, why is that? I think I used to understand this a little bit more clearly, but there's a really subtle difference here. I guess it's that we want to essentially make a copy of the iterator, I think. Or something that basically makes reference, it makes reference to the vector rather than to basically move the vector value into just this for loop. Boy, Rust, it can be confusing. What are all these little underlines I'm seeing here? What is it complaining about? Do the underlines mean local variables, or they mean mutable variables? I think that's what it is. Of course. That is weird. So what was the underline for the plus equals here? Huh, mystifying. Okay. Well, that's fine. So we should have all of our counts now. And maybe just to determine that we've done this correctly, let's try running this on the sample input, actually. So let's run digit counts here. Let's do digit counts. And let's whip out the sample input. from here. Go ahead and replace our actual input. And let's run it. Let's get rid of this. We have 2 and -2. So there are 5 bits of 5 0 bits and 7 1 bits. So that's 7 minus 5, which is 2. The second digit, the most common second bit is 0, which means that our count should be negative. So I think this is mostly lining up with our expectations if we just base it off of those first 2, which is a small sample size, but I think we've done this correctly. All right, so what we want to do now is calculate what gamma is and calculate what epsilon is, and then multiply those 2 together. All right, so I think we want to do a digit. I think for I in 0 input and digit counts, so for each digit basically, we're going to get the count, and I'll explain why I wanted to have the index here. There might be a way to iterate over values and indices in Rust. Let's just double check. Iterate over indexes and values. Items.iter.enumerate. I knew that. So do a tuple here. And digit counts .iter.enumerate, which just takes the iterator that it is working off of and then just creates a tuple with a counter on it. And the reason why we care about I, or maybe let's call it position, the reason why we care about that, and let's actually call it position up here as well, is that that is what we're going to be multiplying by, depending on, yeah, so if we're in the 0th position, what we're going to do is basically take the length, which is 12. Let's actually put that into a variable up here. Let's call it num digits. Use that there. And basically our multiplier is, what do you call the multiplier in each position? Like, so in the first digit in the decimal system, that's you're multiplying by 1. The second digit you're multiplying by 10. The third digit you're multiplying by 100. Is that the radix? I don't know my math terms. Too bad there's too many things that are branded radix. Radix is the base. Let's just call it the multiplier, okay? Or mul. What we're going to do is we're going to say it's basically 2 raised to the power of num digits minus the position, right? Are we off by 1? If num digits was 1, the position is 0, but the multiplier should be 1 and not 2. So I think we need to subtract 1 from here. That's the multiplier. And what we're going to do is we're going to just have let mut epsilon, or gamma, starts off as 0. Let mut epsilon, that starts off as 0. And so if the position is greater than 0, that means gamma will have 1 in that position. So we basically want to do gamma plus equals the multiplier. Otherwise, and then epsilon, we won't modify by anything because the position there would be because the value of that would be 0. Otherwise, epsilon is plus equal to the multiplier. And now we print the product of gamma and epsilon. If count greater than 0. And we need to dereference that, right? Oh, it's the parentheses that you're complaining about. I don't think we need to dereference there because there's some automatic dereferencing that the compiler will do for us. Or no, maybe we do. Yes, I don't want to borrow the literal 0, so let's dereference that reference. Still complaining. Unused import, use core num. That was just typing garbage. Okay, I think we still have the sample input in here, so I just want to see if this runs with the sample input. 792. I really hope that's correct. It's not. Okay, so we'll probably have a mistake somewhere in here. So the gamma rate is the binary 110110 or 22 in decimal. Let's print out everything. Let's print out gamma, epsilon, and the product. $44.18. Okay, so 44 seems to. Are we still off by 1 here? Calculation of this multiplier. The last position in the input is going to be 0, 1, 2, 3, 4, index 4. The number of digits is 5. 5 minus 4 is 1. 1 minus 1 is 0. 2 shifted 0 places. What is 2 shifted over 0 times? It's just 2. So I think we need to basically subtract 2 from here. Well, no, we can't. 2 can never be bit shifted into 1, I don't think. What happens if we left shift by a negative number? Is that even possible in Rust? Rust playground. I must have been playing around with this before. Let's just print the value of 2 shifted over by -1. I bet this is just going to complain. Yeah, this is an overflow. So I think what we actually need to do is we need to say it's really the exponent is the number of digits minus position minus 2. And if the exponent is less than 0, it can only really be -1 here. Maybe a match is better. -1 is going to go to, why is this a U size? Oh, because these are all U sizes. How do I cast these to an integer? As it's -1, the multiplier is 1. If it's 0, I guess if it's anything else, let's just use an if here. Well, technically this I think is going to be smaller. It's going to be 2 bit shifted over by exp, right? And then we don't want to clobber mul. Let's try this one more time. 22,9,198. Okay, so now that's looking correct. So let's get our original input back in there. Hooray for exponent math. All right, we've got our product there, and let's submit that. All right, now we're cooking with gas. Let's go ahead and commit that to Git. And let's go ahead and roll over to part B. Day 03B, and as before, we got to rename this thing. Just make sure it runs. And as we are now learning, we need to reload VS Code. Great. Okay, so while Rust Analyzer is warming up, let's go ahead and read part B. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generating by the CO2 scrubber rating. What is the oxygen generator rating? Is that what we just calculated before? That was power consumption. Both the oxygen, so we're dealing with two new values that we probably have to calculate in a weird way. Both the oxygen generator rating and the CO2 scrubber rating are the values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then keep only numbers selected by the bit criteria for the type of rating value for which you are searching. So there's two different ratings, oxygen generating and the CO2 scrubber rating. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating for which you are searching. Otherwise, repeat the process, considering the next bit to the right. Okay. The bit criteria depends on which type of rating you want to find. To find the oxygen generator rating, keep the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 1 in the position being considered. Are 0 and 1 equally common in any of the digits? They might be once we've eliminated possibilities. To find the CO2 scrubber rating, determine the least common value, 0 or 1 in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with 0 in the position being considered. There's a big example here. Finally, to find the life support rating, multiply the oxygen generator rating by the CO2 scrubber rating to get the value. Okay, this makes sense. It's starting to feel like maybe I need to write some functions to make this a little bit easier to understand. So how about a function that converts a vector of binary characters into its equivalent decimal value. So let's call it binary to decimal. And it will take a vector of characters. Is that what we want? Probably just a vector of, could be Booleans. It's just representing 0 or 1. Call those the digits. And it will return, let's just do an I64. And we're going to do something similar to what we had before. We're going to say that the result starts off at 0. Let num digits equals the length of digits. We technically, I don't think it's easier to type this than it is to type this, so maybe we don't need this. We're going to return that result. And I guess the value, because it's Boolean now, we call is 1. The exponent is the number of digits. Maybe caching it here is fine. Digits. Oh, am I doing TypeScript? Is that proper Rust? Yeah. Digits. And then this math doesn't make any sense anymore. Let's see. Oh, it does. So what we're doing here is if is 1, then the result plus equals the multiplier. And the result needs to be mutable, of course. And I think we need to dereference this. Is that right? Okay, so now let's try. Okay, this is a little bit more complicated now. So what gamma and epsilon become are vectors. This is complicating the program quite a bit. Gamma binary is a vector of bools. And epsilon binary is the same way. Still hasn't figured out what that is. So what we're doing here is we're going to do gamma binary dot push true. And the epsilon binary, we're pushing false into that digit. And then we'll reverse it here. In fact, it almost seems like we could push count is greater than 0 here, and count, what's the reverse of that? Count is less than or equal to 0, less than 0 here. Technically, if it is 0, we don't actually know the answer, but hopefully this is fine. And then we can calculate gamma by doing binary to decimal of gamma binary. And epsilon here is epsilon binary. And what if we pass the vector by value? What happens if we just pass by reference here? Is that fine? It seems a little more correct. And then the multiplier here doesn't matter anymore. None of these things matter. Which means we don't care about the position here anymore. We just care about the count. We don't enumerate anymore. And let's try running this one more time. Somehow I don't think did we get it right? Day03A, Day03B, okay, good. It's a little bit fast writing this thing here, so I'm glad that we were able to get it correct. I so worry that I'm gonna watch the video of this later on. I'm like making such obvious mistakes or doing this a super weird way. But we are trying to get to bed at a reasonable hour tonight, so let's try and plow through this, shall we? All right. We split off that function because we think we're going to be converting binary to decimal more frequently. Trying to remember the problem. We're also going to want to be able to filter a list down by a particular criterion. So one thing we're doing that's pretty common is we are calculating the most, basically returning whether you have more ones or more zeros or a neutral number given a list of these binary numbers, right? So maybe what we can do is we can have like a count get digit bias, right? The bias is what we were calling the count before. It's basically if the bias is positive, then you had more ones than zeros. If it's negative, you had more zeros than ones. And if it's zero, you have an equal number, right? And we're going to pass in some vector of chars. So let's just call it number values, right? Which is a vector of a vector of characters. And let's actually make that a reference. I have a feeling that the fact that we're nesting these things, it might turn out to be a little bit weird in Rust. But let's see. And then we want the digit, which is a U size. And it's going to return a bias, which is a I64. Okay, and that's going to end up looking a lot like what we did here. Except we're not doing it for the outer loop here. We're just doing it this interior loop. So I think it's just this. And let's call it pause here. Okay. So I think we can replace this with get digit bias of input and pause, taking the reference to input. Let's call input values. It's a little bit of a better name here. Input's kind of ambiguous. This goes away. And this little rewrite here hopefully should end up returning the same thing. Oops. Uh, 775,304. That does look like the same thing that we got before. Great. Okay, so we got the digit bias now. I'm going to just compress this down a little bit. I guess we could actually turn this into a reduce. Yeah, why don't we do that just for the sake of the exercise. Reduce. What does the reducing function look like? Why is there a crate that does this? This is weird. Maybe it's just really old. Should be in the standard library. Maybe it's fold in Rust. No, it's fold in some dialects of OCaml, or some of the libraries in OCaml here, but I think it's, I feel like it's reduce, but I don't really remember. Yeah, it is reduce. Usually reduce has like an initial value that you pass in. Maybe it's fold without, oh, okay, it is fold. Self, all right, let's, the initial value that we're going to be passing in is this up here, 0. And then what? I think it's the accumulator here. And it's the row. And then the logic is going to be I don't think we need the return statement here. And let's just comment this stuff out. Let's run it again. Cool, so we just golfed this down. I'm actually not convinced that this is a better way of doing it, but it's one expression, and I think there's a school of thought that this is a little more elegant. Took me a lot longer to remember this pattern, though. And there's something to be said for the fact that I've been trying to do Advent of Code like 3 or 4 years in a row now writing Rust, and I just can't remember how to like do this. I don't remember the order of these values. I don't remember the order of the kind of like parameters that go into the lambda expression here. All kinds of stuff. Okay. Now that we've gotten this far, I think we actually have to like solve the problem in part 2, where what we're trying to do is actually filter down our number set. So what we have to do is we have to get the digit bias. And I think value is going to end up being mutable because we're actually going to like change values over time. And all this like gamma and epsilon stuff goes out the window. We don't care about that anymore. What we're going to do, though, is we are going to be looping over the positions. And each time we do that, we're going to be updating values. And values, hopefully, will be getting smaller and smaller and smaller over time. And hopefully, by the end of getting through each of the digits, we'll actually end up with just one number. But we will have an oxygen number and a CO2 number. So it's 2 different vectors. So this is actually not going to be mutable anymore. We're actually going to have a copy that the oxygen values are basically the values.clone. I hope this is enough to do a deep clone. Although I don't actually think it is. Let's see what happens. CO2 vals is values.clone as well. Okay, so far so good. So we're iterating over the digits, and we're basically going to trim down the oxygen vals and CO2 vals until basically they only have one value left. So we're going to get the bias for the... We're going to actually get the bias. The bias is actually going to be different for each one of these. So if oxygen values.length is greater than 1, we still need to do a reduction here. So we're going to let the bias equal this. And then we're going to have a parallel structure for CO2 values, but we're just interpreting the bias different. We're interpreting the bias differently. So how does the oxygen value how does the oxygen bias get interpreted? The oxygen bias, the bit criteria, for the most common value 0 or 1, and keep only the numbers that with that bit in that position. If 0 and 1 are equally common, keep the ones with a 1. Okay, so now we're going to basically say that the oxygen values, which are just mutable here, the oxygen values are going to equal the oxygen values, but we're going to put a filter on it. Is that Is there such a thing as a filter? Is it called select? .iter.filter. That's why I wasn't saying it. .iter.filter. And the predicate for this, this is a value, which is a vector of characters here, is if the position of the value is equal to 1, if it's greater than or equal to 0. So the digit, which is this, is greater than or equal to 0. Right. Oh, and I keep adding these parentheses. I've been just doing too much C# and JavaScript lately. And then we're going to do the CO2 values here. Now, I think the predicate is going to be the exact opposite, though. And let's verify. The bit criteria for the CO2 scrubber rating, least common value, 0 or 1. And keep only numbers with that bit in that position. Okay, so let's think about this. The most common value here so if the bias is greater than or equal to 0, then we want anything that is equal to 1, right? The bias is saying that the most common value is 1, which means we're going to keep that. Otherwise, actually, I think we can do this expression here. I'm not sure if this is better. We do 0. Oh, these are Booleans. If it's equal to 1, it's true. If it's equal to 0, it's false. Well, what are you complaining about? Oxygen values. It's because it's a reference to a reference. Is that what it's complaining about? Or do I need the curly braces? I don't think I do. I think this should be sufficient. Oh, I think we just got to call collect here. Cloned, maybe? Now we're kind of running into what I was worried about here. When I have like a vector inside of a vector, doesn't really know how to interpret it. Maybe I've come too far. What if we made this We just have to fight Rust a little bit here. The from iterator here is not. So the return value of this is an iterator of vec char global. Oh, global is the lifetime. Right. Okay, I get that this is the generic thing. Why don't you tell me what I'm actually writing here? That's weird. Okay, so what it's returned, it doesn't know how to resolve the double reference here. I mean, I could do something really clumsy like that. Ugh, that's terrible. Jeez. But it compiles. So let's not complain too much about it. What, didn't I just copy this? Oh, 2 periods. And this is when it equals 0. Okay, so the real important logic is the fact that we're getting the bias, which tells us whether the 1s are more common or the 0s are more common, or if they're equal. If the 1s are more common or they're equal, then we want to keep every value that has 1 in that digit. Otherwise, we want to keep every value that has 0 in that digit. Maybe we can simplify this calling this like the want character, which is equal to if bias is greater than or equal to 0, then it's 1. Otherwise, it's 0. And we can trim this out. And the character that we want can just go in there. And now we can copy this over to the CO2 values. And we're interpreting the bias exactly the opposite way. If the bias, that we want the least common value, right? If they're equally common, keep values with a 0 in that position. Okay, so if it is greater than or greater than 0, then the most common value is going to be 1. So we're going to want the 0. Otherwise, we'll want the 1. But what happens if it is 0? If it is 0, then we want the 0s. So I think we just flip it. Then we say let oxy, let's just call this oxyvals. It's easier to type and it matches the same number of characters as CO2 vals. Let's say let's oxy equals binary to decimal of CO2 vals. And the reason why this is complaining is that I'm passing the wrong type in here because this thinks it's going to be a vector of bools. Let's just do vector of characters. And then what we can do here is if char, if the character is equal to 1, then we'll do the conversion. And that should hopefully resolve our type mismatch here. Oops, forgot to rename up here. Should have just done a rename symbol. Okay, so let's see. It is still complaining here about this because I need to actually get the reference here. Oh, and it really should be the 0th, the first of those. Yeah, I was afraid of this. This is the whole vector inside a vector thing. What we really want is to be able to kind of like move the interior stored vectors into the new vector. And here we're in the situation where we start to complain about the borrow checker, but maybe there's a way that we can clone it. Yeah, there we go, v.clone. I have no idea how this actually compiles and whether this becomes something that resembles efficiency. Okay, so the type checker and the borrow checker are all satisfied now. I'm a little bit afraid of this code. So I think what we're going to do is run it on the demo first. I mean, we could just run it on our code right now and just see what happens and see if it works. And if so, then it's correct. Otherwise, we need to debug. Usually it's not this simple. Yeah, it's not. That's too low. Okay, so let's go ahead and take the sample input. And we're going to have to go through the long, hard process of debugging this thing. We're going to run this. It thinks the oxygen is 22 and the CO2 is 10. Okay, so the oxygen one is 23 and the CO2 is 10 here. So we're off by 1, which is fun. Is it that my binary calculation is not working correctly? Why don't we go ahead and just print out what we think oxy vals are and CO2 vals are? And if we got that right, that means our binary conversion is wrong. 1, 0, 1, 1, 0. So I think that's already wrong. It should be 1, 0, 1, 1, 1. Did we get CO2 right? I think we did 0, 1, 0, 1, 0. Just alternating. So that makes me wonder, is there bad logic here? We weren't passing the bias correctly. We want to get the bias of the remaining values, not the original input. So I think that's going to solve this problem. 23 and 10. Okay, that makes me happy. Let's get our original input back. And let's actually not print the values here. Well, it's not a big deal. Get the original input. Fire that away. That looks 1 digit higher than what we had before, so it is greater than our previous answer. Answer's too high. Wonderful. All right. This is the fun situation where the sample input works, but my actual input doesn't, which means I am not accounting for an edge case correctly. So first we were too low, and now we're too high. Yeah, this is 772,002. This is 1,826,292. Oh, I'm passing the CO2 values into this one. These are just silly bugs. All right, that number is smack in the middle of our first two answers. So let's see if that goes. All right. Whew. I feel like we lucked out a little bit. At least our bugs weren't too serious there. That's fantastic. All right, that is day 3 of Advent of Code 2021 in Rust in the bag. Let's go ahead and throw that into Git. And we are done for the night. Maybe we can even go and play video games afterwards if we still got the energy. All right, everybody, that's it. I will see you either tomorrow night or most likely Saturday morning. We'll see how much energy I have on a Friday night. All right, take it easy, everybody.